off, I wanted to talk about a story, just kind of it's about a developer and a software company. So the developer is me. I like telling stories about myself. Lots of fun. So this was me 2.5-ish years ago, graduating from BYU. And I was looking for a job. Little did I know, several years earlier, there was a company. Lucidchart was originally the product that they created. And so this is Ben Diltz. He created Lucidchart. It came out of a need that he had. He worked for a company that was doing insurance type stuff. And they all had a big diagram that had their whole flow and things that they needed to keep track of. And everyone, whenever they wanted to make a change to it, basically sent the new version that they had to some guy who had a license for Visio. And he would try and merge all these different changes that people were making together manually. And so he created this product, Lucidchart, which is basically Visio in the cloud, lets everyone collaborate easily. It's a lot less expensive. So that was his thing. He put it out on the web. People started coming and using it. And he's like, hey, this is actually something people are interested in. So he got together with Carl Sun. He's our CEO. And they created this company, Lucid Software. And so they tried to stay really agile. They were really about getting stuff done, making things happen. Testing-wise, not as important, especially where you're trying to start out a company. It feels like it's not as important. It feels like you need to just really deliver a product, which makes a lot of sense. This was sort of the original development team. This is them at Google I/O, like in 2011. That was everyone. So pretty small team, trying to get stuff done. So when I came around and was looking for a job, I talked with them, was interested in the product. And so there's me again coming along. I ended up being employee 10 to 15. I should probably sit down and really figure it out because it'd be interesting to know. So when I joined the company, I was fresh out of college, kind of learning some things, still trying to figure a few things out. There were lots of hiccups in my early days, things that I did that weren't the greatest practices, some bad releases, some quality issues. Luckily, I had a good manager who was willing to work with me. I actually turned that around a lot and kind of became a lot of the automated testing expert for the company. Helped a lot of people out with things. So you fast forward a couple years to kind of today, say Lucid Software, we now have 2 different products, Lucidchart and Lucid Press. You can talk to me about it afterwards if you want to know more. This is a picture that was taken back in January. This summer we're getting up to about 100 employees. About half of them are in engineering development. So there's me. I'm drinking a Coke. It's lots of fun. And so today I'm leading the Lucid Press team, senior software engineer at the company, and this is my family. They're important to me, so I thought I'd throw that in there. So I thought about coming here to Openwest and was thinking about some of the things I could talk about and my experiences. I like to say I know a lot about testing. The reality is I've made a lot of mistakes about testing, and really the thing that I know best is probably how to discourage testing, just from personal experience as well as from seeing the way other people do things. So what I wanted to talk about today is kind of a few things that I've run into that really can help to discourage testing, so to speak. Obviously that's not what we want. Hopefully we're all here, we understand the importance of testing, why it's important. So these are kind of some things that we can do that are really easy to do that make it so people aren't interested in testing, developers discourage them from doing automated testing, things like that. So we'll go through each one of these and kind of talk about it. I like kind of having things open a little bit, so if you do feel like asking questions, feel free to kind of jump in a little bit. We'll try and keep it, I guess, to a limit until we get through all of the material, more or less, but I'm open to having a few questions thrown in there as we go. So first thing I want to talk about is expectations. So there's a couple things that go into this. One is just not thinking about testing, and the other one is adhering to very strict deadlines. So planning. So we use Scrum. Hopefully a lot of you do. Agile processes, it's a really great way of doing things. Scrum, 2 4-week sprints. In case you're not familiar, you probably all are though. So you get into planning, and you have a bunch of stories that you want to get done, and you start to task things out, and then you decide, oh yeah, we need to do some testing. At that point, you've kind of already failed in making things happen. Like, people are going to be discouraged already at that point. So I mean, if you're trying to discourage people, you did it. Before you ever get to that point where you're trying to decide to do these stories, you need to decide as a team on what it means to be done with a story. And that, if you want to have testing happen, you need to make sure that you're very explicit about what that means. So what does it mean to test? Does that mean that someone reviews it, someone does some manual tests to make sure that the features work? That means you need requirements, right, to know exactly what it means to work. But what does that mean about unit tests? Like, was there a certain level of code coverage that you think you really need to have in order to consider the story complete? What does that mean about end-to-end testing? Like, there's all these questions that come up, and if you don't decide as a team ahead of time on what you're going to decide means done, then you've kind of already lost the battle a little bit. Because if you don't have that in place, you get around to backlog grooming, doing estimation. You estimate things without thinking about testing and where that falls into place with everything else. And then you get to planning and tasking things out. And even if you do at that point, remember, like, yeah, we should do these kinds of things. At that point, you're saying, okay, well, now instead of this being like a 3-point story, now that we've thought about testing, it's really going to be 5. And so you're really setting yourself up to pull back and not want to test things. So not planning is really kind of the first thing that can lead to discouraging testing. Here's a fun Dilbert comic. I'll give you a second to read this one. Lots of fun. Getting some Snickers, that's good. Yep, so deadlines, right? Lots of fun. They can kind of be the enemy in a lot of ways to quality. I mean, obviously, there's a balance there, right? Because if you never ship anything, it doesn't matter how good it is, it's not worth anything. At the same time, if you are so fixed on a deadline that you cut all the corners, then like your user's gonna have a bad experience, you may as well not ship it. So obviously there's sort of a happy balance. And so having these really strict deadlines that don't account for some flexibility and making sure you have good quality, yeah, that's really going to be the enemy of testing. Like, expecting things sooner, don't taking no for an answer, like not allowing for this definition of done we talked about before to actually get to that place and actually adhere to that definition of done, and expecting long hours regularly. These are all kind of the enemy of that. A couple of stories about this. Early on, when I was at Lucid, we're actually trying to port from an old system that we were using that didn't scale very well to a new system. It's been going on for a few years. Probably any of you who have tried to port code over to a new framework know that that's a very long process, especially if you have a large code base. So we were porting, just little things like users logging in and registration and like payments, things that are sort of important, right? And so we decided to do it all in one big go, in one big push. And we worked long hours, and we, made it happen in a short period of time, and it was amazing, all the work that we got done. And then we kind of got down towards the end of where we planned on being, and we realized, oh, we have like all these tests in this old code that we need to put in this new code. And so we kind of threw something together and made it work. And there was lots of time spent going through all of the different endpoints that we ported over from the back end. And there were lots of bugs. I mean, a few bugs. It actually worked out relatively well. But in the end, we ended up with this testing code that was just kind of hacked together, wasn't maintainable. It made it difficult for people moving forward as they wrote more code to go back and write tests. Ended up being a mess. And it kind of came back to this idea of, we had this strict deadline. We really wanted to get it done at this point. And we weren't willing to take a step back and say, okay, this isn't really done. There's these other things we need to do to really get this in a good place and make it more sustainable going forward. And I think no matter who you are, as a developer, or anyone, if you have a strict deadline and you're having to work extra hours, you're going to inevitably cut corners somewhere. And the place that's easiest to cut corners is with automated testing and quality. That's just inevitably what happens. So I don't know that I have a good answer for like where the balance is here, but having really strict deadlines is a great way to discourage testing. So since that's what I'm here to talk about, there you go, you have it. That's how you can discourage testing. I don't have a good answer for that though, otherwise. Sorry. Yeah, it is what it is. I think it's a balance that you have to figure out with each company, but from my view, I think there's a certain point where you just have to be okay saying like this isn't done, don't have good enough quality, and then move forward from there. Frameworks are a fun thing too for automated testing. This is a place where I think you can get a lot of discouragement going on. So at Lucid, we use the Closure compiler for our front end for JavaScript. I don't know. Who's familiar with Google's Closure compiler? Anyone out there? Cool. A couple people from Lucid, and nice. So there's a few categories of tests. So like the compiler will optimize and do a lot of cool things. Occasionally you can have bugs introduced if you know how to do it correctly, it's never a problem. But when you always have new developers coming in and things like that, bugs can come up because of that. So we wanted a testing framework that could use the Closure compiler and be compiled in. And so we decided that that was important enough to write our own framework. In my opinion, that was probably a mistake, as you can see here. So like, this is what the framework looks like. And this is maybe what someone who's written some automated tests might expect, like unit test type stuff to look like. And so I think writing your own framework is probably a bad idea, just because there's so many things you don't think about. There's so many things you don't think about that can come up. So why not have someone else think about it? There's lots of people out there who spend lots of time with testing frameworks, who've thought about it, who know what they're talking about, who've tested it. Why not let them use the work that they've done? And so yeah, that's one area where I found that we've discouraged testing in a lot of ways. Another fun way, having one developer really take on a framework like this, like establishing a pattern. The thing to keep in mind, when you're writing a testing framework like that for automated testing, it's for developers. The idea is they're the users, right? And so you want to keep them in the loop. If you have one person who goes in, I've had this experience before. I was the one who wrote it. I focused on what was important to me, and then it turned out it wasn't very useful to any of the other developers. They didn't know how it worked. In fact, right after this, someone else from Lucid is going to be talking about how he fixed my framework and made it better for everyone. So you should come next hour, hear more about Selenium and some specific stuff we did there. But that was a mistake I made, and it made it a lot harder for developers to understand what was going on. We even had, it made it difficult for other reasons. I'll get to that later. I'll come back around to that. But you have the KISS principle, just keep it simple. Like if you're doing something, try and make it as straightforward, transparent as possible. That's the best thing to do. Next here is in terms of automated testing code. Now don't be up in arms. I know there's lots of QA people here. But I think it's important to have a good layer of abstraction between the two. The testing code really can't be just something that you throw together and hack together and like, well, it's not really going out into production. Like, it's not a big deal. Let's just, put it off to the side. Don't worry about it. It's just testing code. That's a great way to back yourself into a corner and have bad abstractions, bad code, and just a terrible experience all the way around. So we actually had this experience where we had some end-to-end tests that were being run by Selenium, and for a while we had someone who was in QA that we didn't feel comfortable writing code that went to production, but we felt like it would be okay, for him to write this other testing code. It ended up causing a lot of problems. Like the code was bad. It made it difficult for other developers who actually did want to write tests. They looked at it and were like, yeah, I don't want to touch this, kind of set it aside. So it's important to treat the code that's due for automated testing just like you would any other code in the code base. Not as a second-class citizen, second-class code. It needs to be treated just like any other code in your code base. Bugs in test code can just as easily lead to bugs in production code. That's just the way it works. If you have a bug and you think something works and it doesn't, that's a lot worse than, in a lot of ways, than just not testing it. So putting in that test code is an investment like anything else. You're going to get out of it what you put into it. If you put time into writing good automated testing and making the code scalable and making people able to make changes without too many problems, then that investment is going to pay off in the long run. Next up here, fun one, ignoring tests is a great way to discourage testing as well. Don't run the test, don't look at the test results, don't think about who caused the problems in the first place. So we have a Jenkins server that runs builds and runs tests and things, which is awesome. It's great. I highly recommend. Hopefully all of you have some build process in place. The few times that we've missed on having things in that build process, it's really come back to bite us. There was one point where we have a service that its whole purpose is keeping track of images and metadata and things around images. We spent time putting in place a lot of integration tests that actually went down to the database layer, and were just, for that service, end-to-end tests. And then they were never put into a build process, so they never got run. And so it turned out to be a huge waste of time. There are bugs that came up later that could have been caught by tests that we had written and in place, but they weren't being run, so what good did it do us? None at all. We also had a lot of Selenium tests in place, and for a while, they were supposed to be run by a person who was going to give a report and back to us about like what was failing, what was passing, and he didn't really give the report consistently. He didn't tell us about what was happening when tests failed, and so frequently after the fact, we would go through and run these tests, and we found out that a lot of them were catching bugs that we just didn't know about because they weren't really being run. And so that gets back to the same thing. You got to look at the results. Not only do you have to run it, you have to pay attention to what comes back. So even just compile issues, things like that can point out bugs in the code. If that's not paid attention to, then there are big issues there. We have Jenkins builds. Sometimes it's difficult to get people to pay attention to what goes wrong there. Sometimes it's difficult if tests are failing to get people to pay attention. And what ends up happening, or at least what I've seen, is builds get ignored, things build up. There are issues on top of issues that come up. And especially with tests, there are things that really are bugs that need to get fixed. But if no one pays attention to them in like a build process, then it's only the people who are actually writing the automated tests that come back and pay attention. And so again, that comes back to the discouragement part. Like, that's discouraging to people who are consistently writing tests to always be having to go back and fix tests that other people are breaking, or like even tests that they wrote that are breaking by changes that other people made. So a great way to do this is, and Jenkins is really set up for this, I mean, it's great for this, is just linking those failures back to the individual commits. If you're running that build validation on every commit, then you know exactly when something broke, when it failed, and you can go back and tell that person individually that it's their responsibility to fix it. And just being able to pay attention to that test results, link it back to the individual, and make sure tests are passing consistently is really one of those things that's going to help encourage testing. Kind of the last thing here I wanted to talk about is just the element of fear. I feel like a lot of times with automated testing, there's kind of this apprehension to dive into it. Like, there's this hesitation that people have around doing something new, something different, or scared of being wrong, doing it incorrectly. And when I first tried to push more towards doing automated testing, I kind of had this hesitance, this fear of working on testing. The reality is you're going to make mistakes, like as we just saw, going through lots of mistakes that I've made around testing. It's going to happen. Things aren't going to always work out the way you hope they do. But the important part is to just do it. When you're trying to do automated testing, when you're trying to make it happen, it's going to happen eventually. You'll have false starts, you'll have pitfalls you'll run into, but you'll learn from it. And going forward, it's going to be valuable. And in my opinion, writing tests is like learning to code again. It's a whole new way of looking at code. It's a whole new way of thinking about what you're writing, that it really requires going back and relearning a lot of different things. So, like I said, I like to have a chance for interaction. Hopefully you kind of got an idea for the background behind Lucid, where I work, and kind of some of the things we do with testing. So I wanted to open up a good chunk of time here just to let everyone ask kind of questions about some things I've run into. Hopefully I can tell you some more specific things about stuff we've done and ways testing we've discouraged, and then hopefully maybe a few things that we've gotten right or that I feel like we've done well. So anyway, open it up to you guys. I'm happy to answer whatever questions you might have. Yeah, go ahead.
You said you changed code base.
Mm-hmm.
What was that? From what to what?
So we originally, when we started out, we did Cake PHP as a back end, and the back end was really just a tiny piece of our product, which was kind of a mistake. There wasn't a lot of validation going on the back end. So we started adding more and more to that and fixing it up, and eventually got to the point where we realized that Cake PHP was great for starting up, but wasn't very scalable. So we actually switched over. We're using Scala and Play now. And so we switched over also to a service-oriented architecture, so we have a lot of different back-end services that we use. And so the goal is, by the end of the year, to finish porting over from PHP completely. But that's been something we've been working on for about, 2.5, almost 3 years now. So it definitely takes some time and some long-term commitment to get that kind of stuff done. But we've seen a lot of value come out of that. Yeah, go ahead.
Some companies are really anti-Selenium, but it sounds like you're really pro-Selenium because it's too brittle or...
Yeah, I know what you're talking about. Yeah, so it can be kind of a challenge, and I think if you're testing the right things with Selenium, it can be a really great tool. Yeah, I know. Actually, if you're interested in Selenium, the talk, this next session that's in here is by one of my coworkers, Jared Yarn. He's in the back here. He's going to talk a lot about how we use Selenium and what makes sense. The short answer, so I don't give this whole presentation, is we found it's really good for sort of the happy path type cases. And our application is kind of unique. I mean, it's sort of a single page application. There's not, we render a lot of stuff ourselves. So there's not a lot of DOM elements that are easily manipulated. But what we found Selenium to be really useful is for that happy path, for checks that you'd maybe normally do in sort of a QA regression type situation, where you go through and check each of the features and make sure they're still working. We find that it's really good for that. I think the problem people run into with Selenium a lot is they try to do things that are really meant for unit tests, like taking care of special cases and things like that. And that ends up coming back, I think just doing that in place of unit testing, or even like larger end-to-end for single service type testing, is where Selenium really has problems, because even minor changes can really can mess up the test. But there's some other strategies around organizing the code that can really help with that as well. And yeah, if you're interested in that, I would definitely stick around here for the next talk. Like I say, Jared, he'll be talking about that, and he'll have a lot more insights there. But yeah, thank you.
What kind of system do you have in place for running the automated Selenium tests? Because if you're doing a lot of end-to-end tests, a a lot of them, your tests may be dependent on other services. You can't run them like unit tests on Jenkins
Right.
as easily. So you have to maybe like hit an external server that's like has the full environment.
Right, and that is what we have to do with our Selenium tests. So right now, that's one of the things that we honestly don't have a great solution for. Basically, what we have is Jared, who's basically our QA engineer. And so what he does is he'll run the tests and check out the failures. And it really takes, like 3 to 5 hours a week to just manually run those tests in this environment, check it out, and then go through, figure out what's going on, and get information back to developers. We have some plans for improving that, and then maybe we'll come back next year if they're successful and talk some more about that. But yeah, it's a good question. I think that's an issue that lots of people run into. But if you're doing Selenium tests, you really kind of have to have the full environment, the full stack up and running. Did that kind of answer your question?
Yeah, so right now you're just kind of doing it manually.
Yeah, basically. Do you want to talk about it some more?
I know that we've started with on nightly build. We'll just drop whatever the latest master was, the latest good build, and we have another server up, and we just drop a full stack onto that server and start it up, and then run our Selenium tests against just a full stack that we started in the cloud, and they'll run for about 3 hours, and then it'll shut it down and just report the results.
You run those against like things you're about to deploy before you deploy them?
Yeah, I think we also do that as well, right? Yeah, so we'll do it regularly throughout the week. Like I say, you want to be able to link, when tests break, you want to be able to link the broken test back to someone who broke it as quickly as possible. So we try and run them daily, just because they do take a long time to run. So we try and run them at least daily to kind of be able to get feedback as soon as possible and there are changes that break things. Yeah, go ahead.
Do you have any advice or metrics on how much testing is enough testing? Not that I'm saying I want to do bare minimum. I'm a big fan of tests, but some people are like 100% code coverage, and maybe that's overkill. Have you guys come across some consensus?
We haven't found the silver bullet. Nope. Yeah, it's still something we're working on. Like I say, I guess I hesitated to proclaim myself more of an expert than I am. I know a lot, like I say, about discouraging testing from making mistakes. What I found in terms of how much testing is enough testing, I try to test more than I think I need to. That's what I try and go for. I don't know if that's the right approach. It's tough. I don't know that I have a good answer or good metrics for that. I have some ideas of things I'd like to try and do. I was actually just thinking about it earlier that it'd be interesting. People talk about code coverage a lot, and I've read a lot of articles about code coverage to mixed results. People say a lot of different things. Lots of people are like, yay, code coverage. Lots of people are like, no, don't even bother. So I don't really know what to think about it. I think I don't know what to say about it. The heart of the matter is just if people are willing to spend the time to do testing, to do the automated testing, and are willing to do a little more than they think they need to, then that's definitely going to be enough. Again, you don't want to waste a bunch of time. So yeah, like I say, I don't really have the right answer. I think as an industry, we tend to test less than we need to. So generally, a rule of thumb, testing more than you think you should is probably the right answer. But yeah, I don't have a solid number on that. It's a good question, though. Any other questions? Yeah, go ahead.
There are some metrics, industry standards that you look at, and it's best not to just pick one and say, errors per 1,000 lines of code. That's one of them. But then you also need 3 or 4 others. And once you feel that you have a good arsenal of results that you want to compare, you can say, it works, it sells, we're making money. I think we've hit it.
Yeah, I think we're okay. Yeah. One thing that we did try to do, so we actually did try and do some code coverage stuff for a while, but it never really caught on, never really stuck. One thing we've been doing lately is whenever there's a bug that we're fixing, we make sure that there's some test around that. And there's a couple nice things we get out of that. One is that typically the bugs that you find come up again and again. So having a test in place around those is sort of a high value type of test to write. Another thing we find is it makes people at least think about testing at some point. And so that's also just a positive in and of itself. It's really easy to get, just kind of put that on the back of your mind, since it's easy to think that testing doesn't really help with, it's just easy to think that testing doesn't really help, especially if you're not used to writing tests and aren't used to going through that process. It's easy to just dismiss them. So that's something that we have found relatively successful, is just setting that standard. I mean, it's obviously just a starting place for us, but. Go ahead.
The last company I worked at, we had, for every commit, there also had to be a unit test commit as well. So that got the developers thinking testing. For every acceptance criteria, that was pseudocode for the test.
Right.
And I assume you were writing that it's acceptable when this happens. And then you test when this happens, it's acceptable.
Yeah, no, that's definitely a great way. I think that's a great idea. I think that's a great way of doing it. Cool. Any other thoughts, questions, advice for the audience? Yeah, go ahead. Yeah.
I don't know how to phrase this question very well, but what are your thoughts about the life cycle of testing, manual testing, automation testing, and the maturity of products? At what point do you say, there has to be an element of manual testing, there has to be an element of automated testing, the balance of those? You know what I'm trying to say?
Yeah, I think so. Yeah. Yeah, because there are different ways, definitely different categories of testing that take place. One that's interesting is quadrants of testing. I'm trying to remember. I want to say Merrill, maybe, I don't know. I'm not sure. I can't remember offhand who it was that came up with the concept originally, but it's the idea of dividing testing into these 4 categories. And like on one end of the spectrum, so one way, there's like business value versus like technical value, I believe is what it is. I'm trying to remember offhand. And in the other, let's see, it's business versus technical, and then it's the product versus supporting the team. So there's 4 that kind of intersect those different areas, if that makes sense. It'd be something interesting probably for you to look at. But basically there are different kinds of tests that fit in each of those categories. And the theory kind of is, if you're testing from each of those categories, then those are, I don't know, it's just a nice way of breaking it down, because it sounds like that's kind of maybe the underlying question is, there are these different categories, kind of what do they get you individually, and when are each one of them valuable to a company? Like at what phase in a company's life or a product life cycle do those kinds of testing make sense? I think that's still kind of an open question. I don't know that anyone has a great answer for it. It seems like if you're starting out a product, it makes sense to err on the side of speed a little more than testing, but I don't know of anyone who's really tried to create a product and we're very strict about, doing unit tests and doing all good practices for testing right up front. I think it would be interesting to see some case studies around that. But I know that didn't really answer your question, but I'm not sure that there's a great answer for that. So but I think that's a good resource to look at least. You can look up just online Agile quadrants of testing. Yeah, go ahead.
Do you have any way of keeping track of metrics on when you're actually catching regressions versus just when someone broke your tests?
Right. I think we sort of do to a certain extent, yeah. Jared can talk to this more than I can probably. He's been in it more recently.
Yeah, we're at about 50-50 between catching regressions and people breaking tests. We've really gotten on our developers as they started breaking tests and trying to help them think of, okay, these are tests you may need to go and update, or these are tests that may need to fix when you make changes in this area of the code. And as a result, our developers are being a lot more proactive about it and looking at places they can fix the test before
Yeah, but I think that's a good thing to pay attention to. I think it's a good indicator of how good the tests are. If they are breaking a lot, especially if it's like a big end-to-end test, if they're breaking a lot, then that's probably a good indicator that needs to move down a layer, either to a specific end-to-end test for a single server or down to a unit test level. It tends to be easier, I think, for developers to write tests that hit the whole stack because it's easier to think about things that way. You don't have to think about how you're writing the code. So like to do good unit tests, you have to really think hard about how you're writing the code, which I think is good in and of itself. It contributes to just code quality generally. But if you haven't thought of that and then you try and go back and test, it's always going to be a lot harder. That's probably another slide I could have thrown in here is another way to discourage testing is to not, I guess that kind of was the planning phase, to just not think about it ahead of time. Because you need to be thinking about testing as you're writing the code to really be able to put tests down as low a level as you can. Any other questions? I think we're pretty close to out of time. Or thoughts? If you have something you'd like to share about something that's worked well for your company, I'd also be happy to hear it. I'm learning, obviously. Yeah, go ahead.
We noticed as we started trying to test that we hadn't written the code in a way that allowed it to be tested easily, which was kind of what you were just talking about there. And just as a piece of advice for anyone writing that code, Mishko Hevry, the kind of guy behind Angular, first guy behind Angular, he's a big unit testing guru. His blog has many hundreds of words of wisdom on how to restructure your code and how to use certain patterns and avoid certain anti-patterns to make it a lot less painful to test your code. And we kind of follow his school of thought now, and it's made a big difference.
Cool, thanks.
So just throw that out there if anyone wants it.
That's great, thank you. All right, if not, we can wrap it up. If any of you have questions you want to come and talk to me afterwards, feel free to, but thanks for coming out.